This works until it doesn't.
You ask it about something public, a historical event perhaps, or a scientific concept.
Almost instantly, you get a response. It sounds correct. It feels complete.
Then you switch. You give it your own data, company documents, internal notes, team policies.
And suddenly, the answers become vague or incomplete. Sometimes they are confidently wrong. The AI didn't slow down, but something has clearly changed.
The tool that seemed so brilliant just a moment ago now feels unreliable. So the question is, what actually broke?
The answer begins with a quiet but fundamental shift in how the AI is finding its information.
When answering public questions, the AI relies on its training, the patterns from massive amounts of data it has already seen. But when you ask about your data, it has no training. It's working with information it has never seen before.
A common misunderstanding is that the AI learns from your documents, that it remembers them. It does not. The AI has no memory of your files from one question to the next.
So instead of using its vast internal knowledge, the system now depends entirely on the specific information it is given right at the moment you ask. That dependency is where the problems begin.
The process used to handle this is often called Retrieval Augmented Generation, or RAG for short.
At its core, it's a two-step process. First, the system retrieves what it thinks is the relevant information. Then, it gives that information to the AI to generate an answer. Every question you ask starts this sequence. First, your question is used to search through your data. Second, the system selects just a few small pieces that seem to match. And finally, only those pieces are sent to the AI to form a response.
And this is a critical point to focus on. The AI never sees the full document. By design, it only sees small, selected pieces. The quality of its answer is completely dependent on how well those pieces were selected.
So if the answer is wrong, it's often because this process broke down at the very first step.
Let's use a simple example. You ask the AI about your company's leave policy. Your policy document has a section on leave limits and another on approval rules. If the system correctly retrieves the part about limits, the AI gives you a correct answer. But if it retrieves the part about approvals instead, the AI will still try to answer, using the only context it has. It doesn't know it's missing the crucial piece of information.
The key insight is this. The failure happens before the AI writes anything. It happens during retrieval. The problem isn't generation. It's the information the AI was given in the first place.
This brings us to two important ideas for understanding the quality of an AI's answer: grounding and coherence. First, grounding. This simply asks, is the answer strictly based on the provided text? Second, coherence. This asks, does the answer sound fluent and logical?
And here is the core of the problem. AI models are exceptionally good at coherence. They can generate fluent, logical-sounding sentences even when the information they were given is incorrect or irrelevant. This is what makes these failures so difficult to detect. The answer simply sounds right.
This is why the best systems do more than just provide an answer. They provide sources, showing you exactly which part of which document the answer came from. And sometimes, the best response is not an answer at all, but a question asking for clarification.
An AI can feel trustworthy just because it sounds coherent. But true reliability doesn't come from coherence. It comes from grounding, from visible sources, and from a system's ability to know when it lacks enough context to give a correct answer. Understanding this distinction is the first step. This has been a foreview of that core idea.
Tech Foreview.